we're moving on to coordinate geometry and specifically the section of lines. So firstly, just some recap from what we did in IGCSE, where we look at the length of a line and the midpoint of a line. Now remember, a line is just 2 points connected to each other. In this in this example, the 2 points that are connected to each other is A and B. A and B, where A's coordinates are 4 and 7 and B's coordinates are 12 and 16. And you have to find the length of this line as well as the midpoint of this line. And remember, the length of a line was this formula right here. Now I'm going to show you exactly how we get this formula as well, where we had x1 minus x2 squared plus y1 minus y2 squared. Then we square rooted that entire thing, and that gave us the length of that line. And the midpoint was, we just take point-wise, meaning each point x and y, and you take the average of that, x1 plus x2 over 2 and y1 plus y2 over 2. This part is pretty self-explanatory, right? Because the midpoint is just you going to the end but doing half of that. Yeah, so you take the average of those 2 points of the x values, you take the average. So 4 plus 12, which is 16, divided by 2, which is 8. Yeah, and 7 plus 16, which is 23, divided by 2, which is 11.5. And this straight away gives you the midpoint. Just take the average of the 2 x's and the average of the 2 y's, which is exactly what this is. When it comes to this, I want to show you in a form of the Pythagoras theorem. So suppose we had the xy plane, and we had 2 points, which is this one, x1 and y1, and this one, which is x2 and y2. And you want to find the length between them. That means you want to find this thing right here. But remember, this thing right here is a triangle because it has its x values and its y values. How much wide you go, how much horizontally you go, and how much vertically you go. And if this is x1 and this is x2 with y2 and y1, then what this length would be x2 minus x1. Yeah? And what this length would be y2 minus y1. And if you want to find this edge, which is what we are planning here, the distance between these 2 points, so the length, if you want to find this c value, we can take this as a right angle triangle. You can just do a squared plus b squared equals c squared, which then would give us y2 minus y1 squared plus x2 minus x1 squared equals c squared, which is what we want to find. We want to find c, remember here. And so to find c, we just square root both sides. And we square root that, and that's where we get this formula from. Yeah. And from here, we can just sub in the values. So 4 minus 12, or 12 minus 4 squared, plus 16 minus 7 squared. So 12 minus 4 is just 8 squared, which is 64. 16 minus 7 is 9 squared, which is 81. And 64 plus 81 is going to be 145. And so your thing is going to be square root of 145. That's going to be your length. Next part, another question. You look at a parallelogram here. So ABC is a parallelogram where A is -5, -1. B is -1, -4. And then something like this. So yeah, this is A, this is B, this is C. And because it's a parallelogram, we know that these two are going to be parallel, because D would be somewhere here, and these two will be parallel as well. And that gives you the parallelogram. That means in the visual way, this thing right here will be D, right? And first I'll tell you to find the midpoint of AC, which is quite simple. You can do it on your own, yeah, and then you check the notes PDF to check whether your answer was right. But to do it, you just take the average of the x values and the average of the y values, and you get that. And I'm just going to do it right now. It's going to be 0.5 as the x, and the y is going to be -1.5. That's going to be the midpoint. That means this right here is 0.5 and -1.5. Then they tell you to find the coordinates of D. Now, for this, you need to dive deeper into the properties of parallelograms, where one of the properties is that the midpoint is shared by both the opposing coordinates. What do I mean by that? That means AC and BD in this case have the same midpoint. Therefore, BD, the midpoint of it is also this right here. So let's look at BD on its own. B and D. We have its midpoint as well, which is 0.5, negative 1.5. And B is negative 1 and negative 4. And so we have to find now just D. And here we can use a formula where, remember, this is just the average of the two. But another trick that we can do is just see how do we get from negative 1 to 0.5. And the way we get there is plus 1.5. And then do the same thing again. Because this is just halfway to your destination. So you do the same thing again. And so 1.5 plus 0.5 will just be 2. That's going to be your x value. Your y value, the same thing. So negative 4 to negative 1.5. What do you do? Plus 2.5. So you do the same thing again. Plus 2.5. And you end up getting 1. And therefore, this will be the coordinates of D. The general equation of a straight line. There are three ways you can write this. The most common way we have learned in IGCSE is y equals to mx plus c, where m is the gradient and c is the y-intercept. And this helps you because it straight away you can see what the y value is, what the y-intercept is, and the gradient, what it is. Yeah, straight away just from the equation. Second one is this right here, ax plus by equals c. And this one helps you solve simultaneous equations, because this format right here is exactly the format you need for simultaneous equations. And finally, we have this thing right here, which is a different one from what you have seen, but it's the easiest equation to form. Why? You just need one point, right? And we need the gradient. So usually when we had 1 point in a gradient, we would just try to find y equals to mx plus c. Yeah, for most of the people who have done IGCSE. And this formula right here comes from m equals to y2 minus y1 over x2 minus x1. Now, what if x and y were just arbitrary, meaning they were a random x and y, right? It could be anything. Then we replace x2 and y2 with just x and y. Yeah, and that's where you get the formula from. So m times x minus x1 equals to y minus y1. That's where you get this formula from. And now, to get the equation of a straight line, you just need two things. You need the gradient, and you need one coordinate from that line. Yeah, as you saw, gradient, and that one coordinate would give us the y-intercept for most of us that have the IGCSE. And then even in this one, you have the gradient, you just need 1 point with it, and you will get the equation of the line. Now, gradient itself, you do sometimes need two coordinates to find it. So you might ask that, okay, but we already are using two coordinates. And yes, if you are using two coordinates, then that's the only thing you need to find the equation of a line. But there are other ways of finding gradients as well, and we will see it. Use this format to find the equation of a line with gradient of -2 and pass it through this coordinate. So straight away, this means x1 is 4 and y1 is 1. And we can use this formula, this format of the equation, y minus y1, which is 1, equals to m, which is the gradient, which is -2, open bracket, x minus x1, which is 4. And that gives you this right here. And you can rewrite this even, y minus 1 equals to -2x plus 8. Take -1 to the other side, we have y equals to -2x plus 9, which then gives you the y equals to mx plus c straight away. Yeah. Next, find the equation of a straight line passing through these 2 points. And remember, now we have 2 points. With those 2 points, we can find the gradient immediately. And then we also have one of these coordinates that you can use to find the y-intercept if you're using the y equals to mx plus c format, which you're going to do for this. Yeah. So find the gradient first. y2 minus y1, so -2 minus 3 over 6 minus -4. Remember to name them first, yeah? So x1, y1, x2, y2. So you don't get confused here, because it's supposed to be y2 minus y1 over x2 minus x1. If you switch, if you do y2 minus y1 over x1 minus x2, you're going to mess stuff up, right? So it's better you name them so that you know that your x2 and y2 are going to be the same here, right? Negative 2 minus 3 is negative 5. And 6 minus minus 4 is just 10, which then gives us negative a half. That's going to be the gradient. That means we, at the moment, know is y equals to negative a half x plus c. And to find c, we use any one of the coordinates. Let's just use negative 4 and 3. And you put negative 4 in place of x and 3 in place of y. Get 3 equals negative a half times negative 4, which is just positive 2, then plus c. Where then c will be 3 minus 2, which is just 1. So your equation of your line will be y equals to negative a half x plus 1. And that's going to be the equation of that straight line. Perpendicular bisector. Now here, you will see the fact that you don't need the y2 minus y1 to find the gradient, right? y2 minus y1 over x2 minus x1. That's what I mean. So perpendicular bisector means you have two lines that are connecting to each other. And if you remember what we did from IGCSE, perpendicular bisector is that line and then a perpendicular line that passes through the midpoint of that original line. So A, B, then there is that midpoint, and you want to find the equation of this thing right here. That means you want the gradient of this, and you want one coordinate of this, which obviously you would assume would be the midpoint right here. Yeah? So firstly, you can find the midpoint, which is the average of the x and the average of the y. The average of the x here is going to be negative 1. And the average of the y is going to be negative 0.5. Okay, and that's immediately the coordinates of the midpoint of the line AB. Then what else do we need? We need the gradient of the perpendicular line, right? So we know that this is already on the line. So we have the coordinate part of it. Now we need the gradient. And for the gradient, we use a very specific property which is used a lot, by the way, in this topic. So you better know this in and out. M1 times M2 equals negative 1. Given that the line L1, which has a gradient M1, and the line L2, which has a gradient M2, are perpendicular to each other. If line 1 and line 2 are perpendicular, then their gradients multiplied by each other will give you negative 1. And so if we find the gradient of AB, which you can do by 1 minus negative 2 over negative 5 minus 7, which gives you 3 over negative 5 minus 7, which is just negative 12, which gives you negative 1 over 4. That means negative 1 over 4 times M2 equals negative 1 times negative 4 times negative 4. We get that M2 equals positive. So we know the gradient of this line right here, the perpendicular bisector, is going to be 4. And so we can write it as y, where I'm going to use a format that is easiest, y minus y1 equals to mx minus x1. Where y, you leave it as y, y1 will be the y coordinate of the point on the line, which is negative 0.5, y minus negative 0.5 equals to m, the gradient, which is 4, open bracket x minus the coordinate, which is negative 1. You end up getting y plus 0.5 equals to 4x plus 1. And then here you can just rewrite them if you want it into the y equals to mx plus c. And we can do that as well. Y plus 0.5 equals to 4x plus 4. Minus 0.5 on both sides. Y equals to 4x plus 3.5. And that's going to be your final answer here if you want it in the format of y equals to mx plus c.